algebra. Did you know this is just advanced algebra, right? There's no such thing as pre-calculus. That's a fake name. We call it beginning algebra, that's algebra 1, intermediate algebra, algebra 2, and advanced algebra, algebra is pre-calc. And then in calculus, they add in a new variable, and that new variable is time. They start seeing how things change over time. That's what calculus is. It's about the change of time. We don't do that in this level. We just get our skills up. And in algebra, we really do two things. We either solve for x, and sometimes it's easy, like x plus 3 equals 7. And sometimes we start doing things to x. We start torturing him. We start putting things like that on him, or putting things like this on him, or putting things like this on him. And eventually we will get to putting things like this on him. And we will be solving all of these in this class, right? We just take the x coordinate and change the function, right? We just start changing it around. So that's one thing that we do. The second thing that we do in all algebra classes is solve for multiple variables, right? So we might say something like this: 2x plus 3y equals 7. But it turns out I can't actually get an answer for that because I need as many equations as I have letters. So if I have 2 letters, I am going to need 2 equations. And here's what we're heading toward this chapter. We're going to add in more letters. We're going to throw in an extra letter. 7z plus 11z equals 15 or 31. But that can't be done because 3 letters means I need 3 equations. So I'm just going to make one up. 2y plus 2z equals 18. And we will even get to the point, not by hand, but using technology, we'll even do some 4 equation ones with 4 letters. But in higher level algebra classes, it's called linear algebra when you take it in college. If you want to be a math major, they do, like, it's called multivariable algebra, and you can get like up to like 15 different letters and 15 different equations. We will concentrate on 2s and 3s. That's what we're going to do. So we kind of already know how to do the 2s. We learned them in Algebra 1 and we did in Algebra 2, and here we're doing it again. But we are going to get a little fancy here. That's Nana, and Nana's going to, I'm not going to worry about Nana today. We are going to first start by classifying our systems. I am teaching you some new words. They are very easy, but damn if everyone doesn't miss this on the quiz because you don't memorize it. So I'm going to give you some very easy stuff today, super easy, but you're going to have to memorize this at some point. 3 things, 3, not 18, 3. So the first thing I want you to do, please on your paper, draw a banana, a strawberry, and an orange across your paper, across the top. And you can label it classification, classifying systems of equations. And I don't know if you're going to like this better or not because it's not really math. It's vocab. It's just vocab. Classifying systems of equations. And that means we've got 2 equations floating out there. I'm going to let you draw your stuff, but I'm going to keep talking at you. You don't have to worry. I'm going to be giving you eventually like 2 little equations, and you are going to have to tell me what their name is, what type of system they are. That's our goal today. But you have to learn that. And so here we go. So we're going to talk about the most common type, the banana type. It's not really a banana. I just had to come up with some fruit. So the first ones that we're going to talk about, they are called, and you're going to write this down. These on the quiz, I will say classify this system, and you will need to use these words specifically. The first one is called consistent, independent. Consistent means that you're going to get an answer for your problem tonight. So when we do these different types, if it's possible to get an answer, it's going to be called consistent. And independent is a special kind that says you only get one answer. And I am going to show you what I'm talking about. You are going to write this on your paper. You're going to make a little tiny baby coordinate plane. Yay! And you are going to, if you want to dot it, if you want, I don't care how you do it, you're going to draw a line. That is an X, Y kind of line. It's a linear equation. Yay. Now, I'd like you to draw another one that rams into this guy in one place. For example, here he goes. These are called consistent independent systems because they will give you only one answer. And that answer is where they cross right there. And let's just say this is 2 and this is 3. Our answer would be x equals 2, y equals 3. But here's what's interesting. There are no other answers. These lines don't circle back around and touch other places. That's it. There is one answer possible, only one, where they cross. That's the definition of consistent independent. And how do you know if two lines are consistent and independent? Here's the key feature that you want to write down, and this is what's important here. The slopes are different. And you can say it like this. M is not the same as M. So when we start doing these, how will you know? Will you have to graph it? No. You will literally look at the two and think, hey, do you have different slopes? Because if you have different slopes, you're going to cross. You're going to cross, and you're only going to cross at one place. Someone asked me in another class, hey, Ms. T, could they have, what about the B? Can the B be the same? It doesn't matter. Because look at this guy. Let me get rid of this green guy right here. I'm going to get rid of him. Get out of here, dude. Watch what I'm going to do. Do you see how this guy hits right here? That's his B. But I could put a line like this. Guess what? Same B, still consistent, independent, because the slopes are different. Is everybody cool? So in your little thinky brain, kind of look at it, stare at it. Here's what I want you to take away. Consistent, independent, one answer, different slope. Everybody good? That's the definition. Okay. We're ready to go to our friend, Mr. Strawberry. Can I? Yes. Why was that what? Because I tried to think of something that I could find 3 types of. I could have done 3 different types of dogs, but I thought, okay, I wanted you to be able to draw it, so banana. Yeah, sorry. It would have been nicer if I came up with something more clever. Don't judge me. Hurt now. I'm hurtful. That was hurtful. Here we go. Let's strawberry it. Next one. Inconsistent. I feel like I'm spelling this wrong, and I am. Consistent. Remember how the other one said consistent means there was answers, and independent meant there was one? Any guesses what inconsistent means? No answers, right? That's why it's inconsistent. Doesn't matter if it's dependent or independent, there's no answer. So on this one, there is no answer, none. They never will give you an answer. And let me show you what that's going to look like. You might already have a guess at what that's going to look like. I'm going to draw this dude here. I'm going to draw this dude here. Look what they are. They're parallel, right? Thank you so much. Oh, this is for Karen. Took me a minute. I had to like please. So guess what? Parallel lines are inconsistent. No answer. No answer. That's what's important. What does that mean for you? It means this. The slopes are the same, but this is what matters. The B's are not the same. And let me show you why. If the B's were the same, he would lay right on top of each other. We don't want that. We want them to be parallel. So slope same, B different, right? B is different. How many answers will you get? None. No answer. So what you're going to take away from this, no answer, inconsistent, slope is the same. Slope is the same. And that's our strawberry. Got a big finish on the orange. Big orange finish. And it's the weirdest one. And it is called consistent, because we're going to get an answer. Consistent. Dependent. Again with the spelling. Do you know I actually have a social studies credential, but I can't really teach social studies because I can't really spell. So, I have to teach math. Actually, every year I would say to my principal, can I maybe teach social studies? And they'd laugh at me. I'm like, no, you're stuck with math forever. I like math, so it's okay. Consistent independent. I'm going to get answers. Oh, but they're going to be weird. They're going to be weird. And here's what they are. I got a line right here. I'm going to make him black line right here. And guess what? I have another line laying right on top of him. They're the same stupid line. They're the exact same line. They're a trick. They're a trick, right? So if they are consistent independent, they have the same slope. They have the same B, and guess what? They have infinity answers. Infinity answers. Because whatever works for the black line works for the red line too. They're the same line. And you're like, Miss Tia, how is that a thing? I'm going to show you. I am going to show you. Because look at this guy right here. They look like two different lines. They look different. There's this guy over here. There's that guy over there. And you would say, oh, I don't know what they are. But watch what would happen if I got y by itself. I'm going to go ahead and do that. I'm going to move that 5x over. So I'm going to say y over negative 5 equals negative 5x minus 20 times everything by negative 5. Y equals 25x plus, oh, that's a 20, sorry, plus 100. Oh my God, it's the same effing line. Oh, it's the same freaking line. They're the same. Even though they look totally, totally different, they would be consistent dependent. So on your arm, on your leg, on your neighbor's arm, I don't care. I am going to give you some, and I would like you to tell me what they are. So let's start with a nice and easy one. You are going to tell me two things. What's their name? Consistent dependent, consistent independent, inconsistent, and how many answers you get. So take a look. Think about what you have to compare. We're talking about their slopes. We're talking about their B's. Take a look. Oh, I just heard someone whisper, say, what'd you say? It's consistent independent, right? Guess what? Consistent independent is the easiest one. The minute you got different slopes, those babies are crossing. And you're going to get one answer. So if I was going to see this on a test, I would be lazy and write CI, consistent independent, one answer. Easy, easy, right? You got to memorize it. Let's try this bad boy right here. La, la, la. Let me get rid of him. Let's do this dude. Let's do this guy. Now, I'm not going to lie to you. Because I'm a nerd and I do this for a living, I can eyeball these and tell you what they are. You probably can't. So what you're going to want to do is get y equals mx plus b. Get y by itself so you can see the slope and you can see the b, right? So my advice on this one is to, real quick with your neighbors, get y by itself on this dude. Get y by itself on this dude. And then let's take a look and see what we got. And I'll do it with you. I'm going to move that 4 over. So I'm going to get 2y equals negative 4x equal plus 2. I am going to divide by negative 2. So I'm going to say y equals 2x minus 1. That's looking pretty good. I'm going to come over here and do the same thing. Negative 5y equals negative 10x plus 5. Y equals, ooh, look at that. They did not look the same. They didn't look the same to me, but they're the exact same line. So we would call these babies CD, consistent dependent. How many answers? Infinity, infinity. I'm not going to do the last one. You can figure that out. Now we're going to do something weird here. I like this one. I like this one a lot. I would like you, I'm going to take that, I'll make it easy. I'll make it easy. I'm feeling nice. I would like you to write me a line, and you're going to have lots of choices, that is consistent and independent from that line right up there. So here's what I would do if it was me. I would write that in a different form, and then I think in my head, what do I need to change, right? What do I need to change to make it consistent and independent? Only one number. You only have to change one freaking number up there. And you figure out what that number you need to change is. And you can change it lots of ways if you're super lazy. So here's what this guy looks like. If I needed to be consistent and independent, you want to know the easiest way to change it? Yeah, that's all I would do, because I'm not lazy. And what if you made it 13? Yay! It doesn't matter. You just need to change the slope. You got to change the slope. Question? Okay, I want you now to do another one. I would like you to take that guy and make one inconsistent to him. What do you need to change? You don't have to have it in standard form. That's in standard form. But if you want to, I can change this. I feel like with just changing one number up there. What would you change? Here's what. I need them to have the same slope. So I'm not going to mess with that 3, and I'm not going to mess with that y. You know what I'm going to mess with? I'm going to do that. Guess what? Done. I'm done. I'm done. If you went like this, and you said, Miss T, could I do it like this, and then make it plus 14? That's cool. You can do that too. You can do that too. Right? Okay, last thing I want you to do, I want you to take this bad boy. You can put it on my desk. I would like you, on the little filey thing, I'd like you to make an equation that is consistent dependent, but does not look like that. I would like you to make it tricky. What could you do to make it look tricky? Maybe you move some stuff around. Maybe you multiply. Maybe you divide everything. It's up to you. How could you make that look tricky to me so they don't look the same, but they really are the same? And I'm taking it. If you're lazy like I am, I'm just going to multiply everything by 10. Look at that. Done. Maybe you're going to switch things around. Maybe you're going to move the X over and move the Y over. I don't care. All it has to be, though, is the same Y. We have one last thing that we're doing today, and here's what's crazy. I am also going to give you a little bit of philosophy, Miss T philosophy. The last thing that we're doing today is we are going to start solving these babies. And if I told you before, maybe I didn't tell you, there are 4 ways that we're going to learn to solve these babies. Number 1 way, I'm not going to lie, guessing does work. On a multiple choice test, you can guess and plug in numbers, and that totally works. I mean, it's not the most efficient, but it works. The second way we're going to learn tomorrow is how to do this with algebra, right? It's not our favorite way. The third way we're going to learn to do it is a new word called a matrix. And you will actually like it. Matrix, it's going to make you feel, you'll be like, oh my God, that's so nice. and easy. But today we're going to talk about our friend graphing. But I'm going to give you my philosophy. There are two types of graphing in this class. There's sketching, when we don't need to be perfect, and I'm a giant fan of it. And then there's graphing when we need to be precise. On this one, we need to be exact. We need to get the exact, we need them to cross exactly. And when you did this in Algebra 2 and Algebra 1, they gave you graph paper, they gave you rulers, and you had to be exact. I am not a fan of exact graphing. I am a fan of technology. So right now, could you get out for me either a Chromebook or a graphing calculator on my desk? Either one. If you don't have either one of those, sit next to someone who's got a Chromebook or a graphing calculator. Or any, if you have some other kind of calculating device, whatever you got. So here's I'm going to tell you my truth. I have 3 kids. 2 have master's degrees. One is he's getting ready to apply to law school. I made them, because I'm a math person, I made them take calculus in high school, and they all bought graphing calculators because their teachers told them, you're going to need this for college. And all of my kids majored in things that did not require them ever using a flipping graphing calculator. We spent that $120 for those just to live at my house and run out of batteries. Not that a graphing technology is not important, but you have it on your Chromebook, because the best graphing technology that I am aware of is, dun dun dun, our friend Desmos. Because our friend Desmos does it in a much easier way. Now, if you have already spent the money for a graphing calculator, can you use a graphing calculator? Knock yourself out. But I'm telling you, putting that problem that I just had on the board right here, here he is, if you want to write him down, putting him into Desmos, I'll let you do that. It's so easy, right? It is so easy. On the test that we're going to take in 2 weeks, there will be 2 parts. One part is when we're going to do stuff by hand. Will I make you graph by hand? Good God, no. The second part, I'm going to say, pull out your technology. Are you going to pull out your Chromebook? Sure. Are you going to pull out your graphing calculator? Knock yourself out. 2 different types of testing, right? I'm going to let you do that. So if you put that into old Desmos, look how nice that answer is. It's so easy to get. All you have to do, it's so good. I love it. You just click that button and the answer pops up. I'm going to ask you to write it as x equals and y equals. X equals 3, y equals 4. So nuts. Now, if you are a graphing calculator girly and you can do that, here's the next reason why I'm not a giant fan of graphing calculators. But they're okay. Like, there's nothing wrong with them. But I feel like we've given you good technology. Let's use it. Here's what's happening. Look at that crazy one. First thing is, what psycho teacher would make you do that by hand? That's 112. That's a nightmare. Now, if you're using a graphing calculator, you know what you have to do? You've got to get y by itself. Is that impossible? No. But you might make mistakes. Do you know what you have to do to get this into Desmos? Nothing. You literally type it in. You type it in, right? So nice, right? So that's why I'm a big Desmos fan, because I think it's richer technology, but I'm cool either way. And when we're allowed to use technology, I'm going to set it up and say, you're allowed to use technology, and we'll set it up that way. You have 2 parts to your homework. The second part is to practice this. There are 4 of them. So keep it out and start on the back of the homework first, and then I'm going to tell you what you need to do on the other side. So if you have technology out right now, you can go ahead and knock yourself out. Let me pass this out. I am turning off my taping. Goodbye, COVID friends. It's still around. So